Hello everyone, welcome to Akshara IT Foundation. This is Srinivas, your maths faculty. Let us move on to the today's class. Today we are going to discuss the problems in exercises, nothing but sets, right? So we already discussed what is set and what are called well-defined objects, and types of sets also we have discussed in our previous class. Now let us continue the concept-based questions based on these sets. Yeah, first problem. So which of the following collections are sets? So there are four options are given. Which option will be exactly suitable to represent a set? Let us see. First one, the collection of all months of a year beginning with letter Z. Yes. While you are observing the first option, collection of all the months beginning with the letter J. From the letter J, we can write January, June, July. So if anyone takes letters starting from J are getting the same set. So it can be well defined collection of objects. So it can be a set. Let us go through the second option also. The collection of most talented writers of India. Yes, it is not a well defined set because most talented writers in India based on which criteria? Here criteria is not given. So dramatic writers can be there, some other type of writers will be there. So there is no criteria to identify top 10 most famous writers. So this is not a collection of sets. So we can stick to the option 1. Let us go through the second problem. The second one is given. A is a set X such that the set A is given X such that the X will be in the form of Y plus 1 and Y belongs to set of natural numbers and Y less than 6. So when you wanted to take Y value, Y we have to take it from the set of natural numbers and that to less than 6. So Y can be, from this Y can be 1, 2, 3, 4, 5. First 5 natural numbers which are less than 6. Okay, so based on this, can we write the set A? Set A we can write it as, set A elements are in the form of X. Again X is in the form of Y plus 1. Okay, so first element I am taking Y value 1. So X value 1 plus 1, 2. So 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6. So the elements in set A which is satisfies the condition X such that X is equal to Y plus 1 is 2, 3, 4, 5, 6. Okay. Now let us go through the second one. B. Set B also given that X such that X is in the form of Y minus 1. So previous one X is in the form of Y plus 1. Here X is in the form of Y minus 1 and Y belongs to natural numbers. Y we have to take it from the set of natural numbers and also given the condition that the Y value is between 2 and 5. Y value is between 2 and 5. So from this we can write Y value first. So 2 and 5 between natural numbers because Y is a set of natural numbers. So 3 and 4, only 2 elements will be. Now these 2 elements try to substitute here, then X value will get here. First one if you take 3, 3 minus 1, 2 and 4, 4 minus 1, 3. Therefore set B equals to 2, 3. Now let us see the given question, that is, so then which of the following is correct? So we found set A and set B. Now the 4 options are given. Which of the following 4 options are correct? Let us check. So n of A is less than or equals to n of B. N of A is nothing but number of elements in set A. How many number of elements in set A will be? Just count 1, 2, 3, 4, 5. N of A value is 5 and n of B number of elements in set B. Set B having 2 elements. So n of B equals to 2. So accordingly we can write n of A is greater than n of B. N of A is greater than n of B. So among the following options, let us try to check n of A greater than n of B. So option 3 is our required answer. Okay, na? Let us move on to the next question. The third question is given that, if A equals to, set A is given and that two condition, that is x such that x equals to 2 power n minus 1. X is in the form of 2 power n minus 1 format, and n value is less than or equals to 5, and n you should take from the set of natural numbers. So less than or equals to 5. So n value, if you wanted to write, n value can be 1, 2, 3, 4, 5, because n we have to take it from the set of natural numbers, and also less than or equals to. So less than 5, all natural numbers including 5 also we should take. Okay. Now set B. Set B is in the form of, set B directly given the value, that is 2, 4, 8 and 16. 2, 4, 8, 16. Now we need to find out the value of A delta B. So A delta B, we should read it as A delta B. A delta B is nothing but A union B minus A intersection B. So A delta B formula is A union B minus A intersection B. Let us try to find A union B. What is A union B? A union B is nothing but all the elements of set A and all the elements of set B together. Okay, na? So A is having the elements like before that we need to find out the elements in A. So 2 power n minus 1. So first take 1, 2 power 1. 2 power 1 value is 2, 2 minus 1 is 1. Now take 2, 2 square value 4, 4 minus 1, 3. 2 cube 8, 8 minus 1, 7. 2 power 4, 16, 16 minus 1 is 15. And 2 power 5, 32, 32 minus 1 is 31. So these are the elements in set A. So 1, 3, 7, 15, 31. Union B value is 2, 4, 8, 16. 2, 4, 8, 16. So A union B is nothing but all the elements from set A and set B together. So all the elements from set A, set B together means I am writing in order 1, 2, 3, 4, 7, 8, 15, 16 and 31. This is the value of A union B. Now let us find A intersection B. A intersection B means the common elements from set A and set B. Only the common elements from set A and set B. Okay, na? So set A having 1, 3, 7, 15, 31 and set B having 2, 4, 8, 16. While you are observing set A all odd numbers, set B even numbers, there is no common element. So nothing being here. A intersection B will be empty set. Now according to the formula, A union B value is 1, 2, 3, 4, 7, 8, 15, 16 and 31. 1, 2, 3, 4, 7, 8, 15, 16, 31 minus A intersection B is empty set. Okay, na? So A union B minus A intersection B. We already discussed about what is minus. A minus B means, for example, I am telling A minus B means only the elements in A but not in B. That means if there are any common elements from A and B, we need to remove the common elements, and remaining elements from set A only we should take. Okay, na? That is represents A minus B. In case B minus is asking means first we need to remove the all common elements and we should write only the remaining elements from set B. That indicates B minus A. Same here. A union B, A intersection B, there is no common elements. To remove, there is no common elements. So we can forget about the common elements. Then only A union B elements. A union B elements means these only. So therefore the answer is option 2 will be the correct option. Okay, na? So let us move on to the problem number 4. Yeah. The fourth question is given that if A equals to x such that x equals to in the form of 3 power n, where n is less than or equals to 6 and n belongs to natural numbers. So natural numbers are starts with 1. So if you wanted to write n as 1, 2, 3, 4, 5, 6, because less than or equals to less than 6 and 6 also we should take. So based on that, try to find out the A set A having the elements. First I am taking n value 1, so 3 power 1 value 3. Next 3 square 9, 3 cube 27, 3 power 4 81, 3 power 5 243, and 3 power 6 729. Okay, na? So these are the elements from set A. Now let us see the set B condition. The set B is given that x such that x equals to 9 power n. X such that x equals to 9 power n. So x elements in x are in the form of 9 power n, where n less than or equals to 4, and n belongs to natural numbers. So let us try to write the set n first. So less than or equals to 4 from the set of natural numbers. So 1, 2, 3 and 4. Now let us try to write the set B. Set B equals to take n value 1, then 9 power 1 will be 9, 9 square 81, 9 cube 729, and 9 power 4 729 into 9. So 9 9s are 81, 9 2s 18, 18 plus 8 26, 9 7s are 63, 65. So 6561. So finally we found set A elements and set B elements. Now the question is, which of the following statement is false? We need to find the false statement. Let us see the first option. The first option is given that A union B value. A union B means what? All the elements from set A and set B together. So set A and set B together means 3, 9, 27, 81, 729, 243 and 6561. Yes, A union B is a correct option which is given, but we need to find the wrong option, false statement. Let us go through the second option. A intersection B. A intersection B is a false statement, because while you are observing the elements in A intersection B, 9 is there. Yeah, element 9. A intersection B having the element 9, 81, 27. 81, 729 and 6561 is also given, but A intersection B means only the common elements. What are the common elements here? 9, 81, 729. That's it. There is no 6561 as a common element. So second option is our required answer. False statement. Okay, na? So let us move on to the next problem. Problem number 5. Yeah. The question number 5 is given that the total number of elements in the power set of a set A containing n elements. Set A is containing n elements. The number of elements in power set. What is power set? Set of all subsets of a set A. Okay, na? Let us take one example here. So I am taking set A having elements like 1, 2, 3. 3 elements are there. Then what are all possibility subsets? First subset is 5. We discussed already empty set or null set or void set. We can call void set also, VOID. Okay, na? Empty set is subset of every set. Now single element sets. So single element 1, single element 2 and single element 3. Now double element sets like 1, 2, 1, 3 and 2, 3. And triple elements 1, 2, 3. So total number of subsets here 4 and here 4. Total number of subsets are 8. So simply we can take that number of subsets formula also we discussed 2 power n. So 2 power n is nothing but 2 cube, that is equals to 8. Now according to this question, number of elements n, then the number of elements in subset is 2 power n. Okay, na? Number of elements in subset is 2 power n. So your option will be 2. Now let us move on to the problem number 6, that is, if A is the set of all positive integers, A is the set of all positive integers means only natural numbers we should take. So 1, 2, 3 and so on. All positive integers indicates infinite set because there are infinite number of elements in the set. Okay. Next, and B is the set of all negative integers. B is the set of all negative integers. That means -3, -2, -1 and so on. These are the set of negative elements. A union B is nothing but all positive and all negative, but not 0. 0 we should not take because 0 is neither positive nor negative. So according to your option, the set of all integers are wrong because integers having 0 also a number. Now second option, only set 0, wrong that one. Third option, the set of all integers except 0. Option 3 is our required answer. Our required answer is option 3. Now let us check question number 7. The seventh question is given that if A equals to set of elements 2, 3, 4, 5, 6. These are the elements from set A. Now set B 3, 4, 5 and so on. Set B having 3, 4, 5 and so on. And A minus B intersection C value. A minus B intersection C value we need to find. First B intersection C we have to find, but A and B only given, C is not given. C, the set is not given, or it can be the printing mistake also. Okay, na? So this problem we are going to leave it because if we know the set C only, we are able to find out B intersection C. But B intersection C is not given, so let us omit this problem. Now 8th question. Okay, the 8th problem is if A is equals to 1, 2, 3, 4, 5, first to 5 natural numbers 1, 2, 3, 4, 5. Yeah, this is list form or roster form. Okay, and B equal to 4, 5. B is equals to set of 4, 5. Then A delta B. I told you already A delta B is nothing but A union B minus A intersection B. A union B I am directly writing. So A union B is nothing but all the elements from set A and set B together. So let us try to write all the elements from set A, set B is nothing but set A itself again. And A intersection B is nothing but 4, 5. Now A union B minus A intersection B, that equals to only the elements. Let us identify the common elements first for subtraction. The common elements 4 and 5. I am just removing the common elements and remaining elements from A union B. A union B remaining elements is 1, 2, 3. So therefore the required answer A delta B equals to set of 1, 2, 3. 3 elements. Okay, na? So let us move on to the next problem. That is problem number 9. The 9th question is given that given n equal to 1, 2, 3 and so on 100. N is equals to set of numbers up to 100. Okay, first 100 natural numbers, nothing but. then subset B of n whose elements are represented by x plus 2 where x belongs to n. Okay, let me read the question one more time. Yeah, then subset B of n whose elements are represented by x plus 2 where x belongs to set of natural numbers. X belongs to set of natural numbers. So there might be a mistake in the question, just wait a moment. Yeah, let us try to write the cell elements in its subset, nothing but it is given that, let us take element y is in the form of y is equals to x plus 2 is given. Okay, na? So let us try to take x value because we have to take only the subset of n. Subset of n is taken as b. Okay, na? Take first number 1. So 1 plus 2, 3. Next 2 plus 3. 2 plus 2, 4, 5, 6 and so on, 100 will be. Because it cannot cross the 100. Even the last element is 100, it will be 100 plus 2. But 100 plus 2 is 102. 102 is not in the number in the given set n. We have to take only the possibility subsets. These are all can be the possibility. 3 can be possibility, 4 can be possibilities, 5 like that and so on up to 100 only. When it crosses 100, we cannot take it because 101 is not an element in the given set n. So 101 cannot be the subset. So up to 100 we should take. So our required answer is 3, 4, 5, 6 up to 100. Okay, no? 3, 4, 5, 6 up to 100, nothing but the second option. Okay, so let us move on to the problem number 10. Yeah, the 10th question is given that if a comma b, if set of a comma b something equals to a comma, it can be the printing mistake, it can be the set A or set B something. Okay, then the power set of a, it is a is equal to a comma b. Power set is nothing but set of all subsets. Power set means P of A we should write. Power set of A. So first one, power set meaning is nothing but set of all subsets. Subsets means first subset always 5, nothing but empty set. And single element set A, single element set B, and the combination of set A comma B. So according to the formula, we know 2 power n. N represents number of elements in the set. Here how many elements are there? 2 elements. So 2 square value 4. 4 elements we are able to write. In that 4 elements, one might be the empty set. So empty set, set A, set B, set of A comma B. So these are the elements in power set of A. Elements in power set of A. Okay. Now problem number 11. Yeah. The 11th question is given that the number of elements of a set x such that x belongs to n and x square equals to 1. So there is a set x such that x belongs to n and x square is equals to 1. Now let us try to take the x belongs to n. N means set of natural numbers. There are a lot of natural numbers. Natural numbers are nothing but 1, 2, 3 and so on. Okay, na? But here one more condition is given that x square value should be 1. Now let us take the first one. In the place of x, take 1. 1 square value 1. Yes, we got 1. 2 square value 4. So 2, 3, 4 anything will come means it is definitely more than 1. So according to this set having only element 1 because of the condition x square value 1. Where n is set of all natural numbers is option 2, only number 1, option 2. let us move on to the problem number 12, that is given that which of the following is an empty set? So empty set is nothing but there is no element in a set is called empty set. Okay, let us see. First option, x belongs to real numbers. Let us go through the options. X such that x belongs to real numbers and x square minus 1 equals to 0. X square minus 1 equal to 0. Okay, so there are a lot of numbers. Real numbers are nothing but set of rational and irrational numbers together are called real numbers. So it definitely cannot be an empty set because 1 we can take. 1 is set of natural numbers. We know already all natural numbers are real numbers. So if you take 1, 1 square minus 1, 0. So there is a chance of elements is 1 and minus 1 also. Minus 1 we can take in from the negative integers. Minus 1 square value plus 1, 1 minus 1, 0. So if you want to take any numbers from real numbers, so it can be satisfies x square minus 1 equal to 0. There are two elements minus 1 and 1. Okay, now second one, x belongs to real numbers, x square plus 1 equal to 0. Second option, x such that same condition x belongs to R, but this time x square plus 1 equal to 0. So if you take any number, whether it is a positive or negative, if you square that number, it will be positive. So for that one, plus 1 will give the positive answer. It cannot be answer 0. So such type of numbers are not available in the set of real numbers. This indicate exact the empty set. Second option will be indicate the exact the empty set. Let us go through the third option also. We'll revise. We'll look into the third option also. X as x belongs to real numbers, x square minus 9. Yes. In the place of x, if you take 3, 3 square value 9, 9 minus 1, 0. Yes, first element 3. Minus 3, if you take minus 3 square also 9. 9 minus 0, 2 elements, minus 3 plus 3 will come. So it is not an empty set. Now option 4, x square is equal to x plus 2. X square value, x plus 2 value can be equal. Let us check. Option 4 is somewhat different. So x such that x belongs to R, that is equals to x square is equals to x plus 2. Okay. If you take in the place of x, 1, if you take 1 square value 1, 1 is not equals to 1 plus 2, 3. 1 and 3 not equal. Yeah, if you take 2, 2 square value 4. So x value 2 we are taking 2 plus 2, 4. 2 square value 4, 2 plus 2, 4. So there is a element x as 2 and minus 2 also possibility. Oh, sorry, not minus 2, only one element. Singleton set. So according to the all four options, our required answer is 3, which exactly shows the empty set. Okay. Now let us move on to the next problem. Yeah, problem number 13, which is given that. So in a class of 30 students, 10 take mathematics and 15 take physics. So there is a Venn diagram is given. So first circle represents mathematics, second one is physics, and this rectangle represents the universal set. Universal set is nothing but set of all subset under consideration of a single set is called universal set. What is that? Set of all subsets under consideration of single set is called universal set. Here common one x. Yeah. So mathematics is 10 members, physics is 15 members. 10 take neither. 10 members are not taking anything. Then the number of students who take both mathematics and physics. So let us take the mathematics and physics. Now mathematics I am taking with M or A. Mathematics we can take it as A. Here I am writing here. Math subject I can take it with the set A and physics subject with the set B. We are having the fundamental theorem in set, that is n of A union B is equals to n of A plus n of B minus n of A intersection B. Here n of A union B is nothing but consideration of total number of students in this universal set. So that is 30. N of A taken as only the elements in math. Math 10 students has taken and physics 15 students are taken, and n of A intersection B, let us find out first. N of A intersection B we don't know. That means common. How many are taken both maths and physics? Right? A intersection B. A intersection B means what? All the elements in set A and set B together. That means the people who are taking math subject, physics subject together are called A intersection B. Okay, na? So we need to find that only, right? The number of students who take both mathematics and physics. So from this 10 plus 15, 25. So plus 25 transpose this side becomes minus 25. That is n of A intersection B. So 30 minus 25 is 5. So both the physics and maths is taken by the 10 students. Sorry, 5 students. Yeah, actually here one more condition is given, 10 take neither. So 10 are not taking anything. So from that only we are talking about this, no? So out of 30 students, 10 are not taking anything. So n of A and B can be taken only 15 you can take. Sorry, 20. So 25 minus 20 will be 5. This is our required answer. Like this also we can do it. Okay, na? Now let us move on to the question number 14. Yeah, 14th question is given. A is equal to x such that x is equal to 3n, and also n belongs to integers. So n value all positives, all negatives, including 0 also we should take. And b is equal to x such that x is equal to 4n. B is equals to x such that x is equals to 4n. I think here also n belongs to integers. Okay. Now then A intersection B. A intersection B value we need to find. Okay. Let us find what is A. If you take n value 1, 2, 3, 0 or minus 1, minus 2, minus 3, they are just coming as a multiples of 3. A is nothing but multiples of 3. Okay, na? Multiples of 3. Now what about B? B is multiples of 4. B is multiples of 4. A intersection B means multiples of 3, multiples of 4, both we should get it. Let us take some examples here. For example, I am writing only positive multiples. So 3, 6, 9, 12, 15, 18, 21, 24 and so on. These are all the multiples of 3. Now multiples of 4, 4, 8, 12, 16, 20, 24 and so on. Now while you are observing here, the numbers which are, that means the common elements, A intersection B means both 3 and both 4 together. 3 multiples, 4 multiples together means here 12 is a common element. Next 24 is a common element. So 12, 24 nothing but to find the common multiples we need to do LCM. So LCM of 3 and 4 is, LCM of 3 multiples and 4 multiples will give 12 multiples. So A intersection B will be 12 multiples, which is comes in 3 multiples and 4 multiples also. Okay, na? So our answer is 12 multiples. Let us see the question number 15. Yeah, 15th question is x such that x square equals to, very important one, this one. So set here, right? Yeah, sorry. X equals to x such that x square minus 12x plus 20. X square minus 12x plus 20. It is nothing but a quadratic polynomial. Okay, and y is equals to x such that x square plus 5x minus 14. plus 5x minus 14. Okay, na? So then x minus y value we need to find. Let us try to find the x value first. Now I am taking the quadratic equation x square minus 12x plus 20. So this quadratic equation, try to find its factors equal to 0. Actually we have to take it. Both we have to take it as equal to 0. Now how to find the factors? By splitting the middle term. Now x square coefficient is 1, constant term is 20. So 1 into 20, 20. Now 20 factors we need to write. 20 factors. I am taking from starting 1 table 120s, 2 table 10 times, 3 table won't come, 4 table 5 times, 5 table 4 times, 4 5s, 5 4s repeating. So these are all the factors of 20. Now when you add, but we here, when you add you should get the middle term. When you multiply, the product will be 20. Multiply, the product will be 20 only, definitely, because we have to take only factors. We are taking only the factors. Now addition will be 12. 12 chance is second one, 2 plus 10. For getting 12, we should use 2 and 10 as a common factors. Look, like x square, this 12x we are splitting as, 12x we are splitting as minus 2x minus 10x, because both are negatives. We should take negative into negative positive, 2 times 20. When you add minus 12x, you will get it plus 20. From the first two factors, we can take x common, x minus 2. From the last two terms, 10 common, x minus 2. Therefore, x minus 2 into x minus 10. So, x minus 2 equal to 0, x is equal to 2. Now, here x minus 10 equal to 0, x is equal to 10. So, therefore, the elements are 2, 10. Similarly, try to find the y values. Y also x square plus 5x minus 14. Now minus 14, 1 into minus 14 is minus 14. Now 14 factors, 1 table, 1 14s are 14, 2 table, 2 7s. Next again 7 table, 7 2s only will come. These are only the factors. But here minus should come means both of them we should take alternate opposite symbols. So here plus symbol, no, so bigger one plus, smaller one minus. Now check 7 minus 2, 5. So the second one is exactly suitable. So let us try to split it here. X square, this 5x we are going to write as minus 2x plus 7x minus 14. From the first two terms take common x. So it will be x minus 2. Here last two terms 7 common. So x minus 2. So x minus 2 take common, will get x plus 7. So x minus 2 is equal to 0, x value 2. X plus 7 equal to 0, x value minus 7. Therefore, this set indicates 2 comma minus 7. But actually what we have to find, we need to find the value of x minus y. X minus y or x difference by nothing but only the element in x but not in y. Element, first common elements we are removing here, common elements 2 removing. So after removing only the elements from x, only 10. So your answer will be 10. If you are taking the same question as y minus x, the answer will be minus 7. Okay, no? Yeah, option 2 is the right option. Let us move on to the question number 16. Yeah, 16th question is given. If n of mu, here mu represents the set of universal set. This we should read as mu, mu. Okay. The elements in the universal set is 60 and n of a 21, n of b 43. N of a equals to 21, n of b equals to 43. Okay. Then greatest value of a union b and least value of a union b. A union b greatest value and least value. Okay. For example, A union B maximum number of elements will come. A and B are at most different elements. Then A and B having greatest values means all elements of set A and set B together. So that means n of A, n of B are not having means set A and set B not having any common elements, then we are writing all elements in set A, all elements in set B together. That means 21 plus 43, nothing but 64 elements will be. But actually, the 64 elements we are not able to take because here universal set also given n of u. N of u is nothing but set of all elements. Total elements 60 only. But while you are adding here, it is getting 64. 64 we are not able to take. If n of mu is not given, the greatest value will be 64. But mu is given, no? So if it is crosses mu value, mu only the highest. So n of A union B is equals to 60, greatest value, and the least value. When you are having the least value, n of A, n of B both having together. For example, A is having elements like 1, 2, 3. B is having the elements like 1, 2, 3, 4. Now A union B will be 1, 2, 3, 4. This is the least situation. Because that means A must be subset of B, you will get the least value. So least value obviously 43. Okay, na? So 60 and 43 will be our required answer. Now let us move on to the next question. So problem number 17. In a school having 200 students, 120 play football. So football players 120, n of F, I am taking F indicates football, okay na? 120 people, and 70 play cricket. Cricket or 70. Next, and 60 play, both number of students play neither football nor cricket. Football and cricket opposite. Okay na? Neither football nor cricket. Neither F nor C. 60 members are there. Total number of students, total is equals to 200. Total number of students equals to 200. Okay na? Now, we need to find 60 play both. Sorry, 60 play both means intersection is given. F intersection C 60. Now we need to find neither the number of students play neither football nor cricket. Both games. Who are not playing football and cricket, we should find it. So let us find out the n of A union B. N of A union B is equals to n of A plus n of B minus n of A intersection B. N of A consider football, n of B cricket. A intersection B means both. Okay na? So that means both are playing. N of A and B here indicates that any one of the game can be played by the students. Either they can be played by football or cricket, or both of them. All together comes here. Now n of A we are getting here 120, n of B 70 minus 60. So 120 plus 70 is 190, 190 minus 60 is 130. This is the number of people plays either of the game. Either football they will play or cricket they will play. But the question is asking neither of them. So total students minus 130. So required answer equals to 200 minus 130 will be 70. 70 members are not play any one of the game here. They will not play cricket, they will not play football. Okay, let us move on to the next problem. Okay, 18th one. A group of 30 people take either tea or coffee. 30 people can take either tea or coffee. Either tea or coffee means it can be A union B value. Okay. Next, 12 people do not take tea and 15 people take coffee. Coffee we are taking as B. B is coffee, A is tea. Okay na? So 15 people take coffee, and here 12 people do not take tea. Negative. That means A complement. This we should read it as complement. A complement means not A. They are not taking. T is 12 members. A complement value 12. Okay. And what you have to find? Then the number of people who take T. Number of people who take T, we should find it. Yeah, let us take N of A union B equals to N of A plus N of B. N of B is nothing but, N of B is nothing but T, N of A intersection B. Now A union B value is, let us consider 30, and N of A we don't know, but N of A complement. A complement means 30 minus 12. A complement is nothing but mu minus A. Here total number of students are 30 only now. Here A and B are working as mu. Mu minus A is equals to mu minus A value is 12. A dash. Mu minus A dash. A will be mu minus A dash. Or A dash will be mu minus A. Same. Similarly, so 30 minus 12 will be 18. So your answer can be 18 directly. Directly you can write it 18. We don't need any formula here. So this formula is enough. 18. Okay now? So let us move on to the next problem. Right. So that is given that sets A and B have 3 and 6 elements respectively. So N of A having 3 elements, N of B having 6 elements. Okay, 3 and 6 elements respectively. What can be the maximum number of elements in A union B? As we discussed in our previous class, A union B maximum elements means 3 plus 6 together. Because your mu value is not given now, so 9. Maximum number of elements are 9. So last question, that is N of mu is equals to 100. Mu is nothing but set of universal set. Mu is equals to 100. N of A is equals to 50, N of B 20. N of B 50, N of B 20. Now A intersection B 10, A union B whole complement we should find. A intersection B value 10, A union B whole complement. N of A union B whole complement we should find. Let us find out the value of N of A union B. N of A union B formula is N of A plus N of B minus N of A intersection B. So N of A value 50, N of B value 20. So 50 plus 20 minus A intersection B value 10. 50 plus 20 is 70, 70 plus 10 is 60. But A complement is asking here. N of A union B whole complement. Complement or dash here. We can write like this. This is also a reading as complement. A complement only. Here also C. C we can write it as N of A union B whole complement. Complement means the elements which are not from A union B but from universal set. So that is nothing but this formula is nothing but N of mu minus N of A union B. A complement means mu minus A union B. Mu value is 100 and A union B is 60. 100 minus 60 is 40. So this is our required answer. Okay na? So that's it for today children. Thank you one and all. Have a nice day. Bye bye.